Measurement error can come from four sources. Subject includes many factors, including mood, motivation, fatigue, health, fluctuations in memory and performance, previous practice, specific knowledge, and familiarity with the test items. Testing are those due to lack of clarity or completeness in the directions, how rigidly the instructions are followed, whether supplementary directions or motivation is applied. Scoring relate to competence, experience, and dedication of the scorers and to the nature of the scoring itself. Instrumentation includes such obvious causes as inaccuracy and lack of calibration of mechanical and electronic equipment. It also refers to the inadequacy of a test to discriminate between abilities and to the difficulty of scoring some tests. Appropriate for reliability coefficients. The degree of reliability is expressed by a correlation coefficient, ranging from 0 to 1.00. The closer the coefficient is to 1.00, the more true score is assessed. Reliability is established in several ways. Validity coefficients are assessed using simple correlations, Pearson correlation. But it is not appropriate for reliability. What's wrong with Pearson coefficient for reliability? 1. It is a bivariate statistic. In other words, interclass correlation is not appropriate for establishing reliability because two values for the same variable are being correlated. Reliability is a univariate situation. 2. Pearson coefficient is limited to 2 scores. What if you have more than 2 trials? 3. Pearson does not provide a thorough examination of sources of variability between multiple trials. Rather, we use intraclass correlation to calculate reliability coefficient. This method uses ANOVA technique used to estimate reliability. It examines differences between trials. In the following slide we will talk about the method to calculate reliability coefficients. There are generally 3 methods of establishing reliability. 1. Determining stability. Test-retest across days. The coefficient of stability is determined by the test-retest method on separate days. This method is used frequently with fitness and motor performance measures but less often with pencil and paper tests. Intraclass correlation between scores should be used to calculate the coefficient of stability. To construct alternate forms involves the construction of 2 tests that supposedly sample the same material. It is a widely used technique with standardized tests, such as those of achievement and scholastic aptitude. This method is rarely used with physical performance tests. 3. Obtaining internal consistency. Some common methods are: same-day test-retest is used exclusively with physical performance. What about the written test? Split half for written tests. The test is divided in 2, and the 2 halves are then correlated. Formulas to estimate from one administration. Kuder-Richardson, coefficient alpha is sometimes referred to as the Cronbach alpha coefficient. It is a generalized reliability coefficient that is more versatile than other methods. Brewster reliability. It refers to degree to which difference testers can obtain the same scores on the same subjects. The degree of objectivity can be established by having more than one tester gather data. 2 testers. Score same test. Compute intraclass correlation coefficient. Inter-observer agreement IOA is coding reliability. It is the agreements divided by the sum of agreements and disagreements. Standard error of measurement. Every test yields only observed scores. We can obtain only estimates of a person's true score. It is much better to think of test scores as falling within a range that contain the true score. The formula for the standard error of measurement is standard error of measurement equals standard deviation times square root of 1 minus reliability coefficient. It gives a range where the true score is likely to fall. It based on the normal curve. About 2/3 of all test scores fall within plus or minus 1 standard deviation of measurement of their true scores. In other words, there is about a 68% chance that a person's true score will be found within a range of the obtained score positive or negative the standard error of measurement. In sum, higher reliability or lower standard deviation produce smaller standard errors. All the 4 types of measurement scales levels of data. Nominal variables classify data into categories. This process involves labeling categories and then counting frequencies of occurrence. It is the categorical data such as gender. Ordinal is one where the order matters but not the difference between values. For example, you might ask patients to express the amount of pain they are feeling on a scale of 1 to 10. A score of 7 means more pain than a score of 5, and that is more than a score of 3. Interval is a measurement where the difference between two values is meaningful. The difference between a temperature of 100 degrees and 90 degrees is the same difference as between 90 degrees and 80 degrees. Ratio has all the properties of an interval variable, and also has a clear definition of 0.0. When the variable equals 0.0, there is none of that variable. Variables like height, weight, enzyme activity are ratio variables. Temperature, expressed in F or C, is not a ratio variable. A temperature of 0.0 on either of those scales does not mean no temperature. Standardized scores. Direct comparisons of scores are not meaningful without some point of reference. Is a score of 46 centimeters on the vertical jump as good as a score of 25 push UPS? How can you compare centimeters and repetitions? Standard score allows for comparison of scores on different scales. It is based on the normal curve. A standard score is a score expressed in terms of standard deviations from the mean. Standardized scores. The basic standard score is the z-scores. The z-scale converts raw scores to units of standard deviation in which the mean is 0 and a standard deviation is 1. The formula is z equals x minus m divided by standard deviation. T-scales. The t-scale sets the mean at 50 and the standard deviation at 10. Therefore, the formula is t equals 50 plus 10 times z-score. This moves the decimal and makes all the scores positive. A score 1 standard deviation above the mean is a t-score of 60. Types of measurement. 1. Movement. Much of research in physical activity obviously involves movement. Examples: health-related physical fitness and skill-related physical fitness. Types of measurements include tests of basic movement patterns, sport skills, and controlled lab tasks. Videotaped observations. The reliability and validity of all forms of measuring movement must be defended by the researchers. 2. Written responses. Research questions frequently deal with affective behavior, which includes attitudes, interests, emotional states, personality, and psychological traits. 3. Affective behavior. Affective behavior includes attitudes, personality, anxiety, self-concept, social behavior, and sportsmanship. Behavior. Measuring affective behavior relies on self-report. Researchers usually try to locate an instrument that has already been validated and that is an accepted measure of affective behavior rather than constructing a new one. When measuring affective behavior, we should encourage honesty by confidentiality, and carefully construct scales to avoid socially desirable responses. as well as ensure response categories are clear and not vague. Generally speaking, there are three types of scales for effective measures. 1. The Likert type scale is usually a 5 or several point scale with assumed equal intervals between points. The Likert type scale is used to assess the degree of agreement or disagreement with statements and is widely used in attitude inventories. Hand out an example in class. Some recommend 6 to avoid neutral response. 2. The semantic differential scale makes judgments about concepts by choosing intervals between bipolar adjectives. The scale is based on the importance of language in reflecting a person's feelings. 3. Rating scales are sometimes used in research to evaluate performance. To do this in a systematic and structured manner, the raters need to have some kind of scale with which to assess skill levels in different parts or phases of the performance. Measuring knowledge, we need to analyze test items first. The purpose of item analysis is to determine which test items are suitable and which need to be rewritten or discarded. Two important facets of item analysis are determining the difficulty of the test items and determining their power to discriminate between different levels of achievement. Item difficulty is usually accomplished easily. You simply divide the number of people who correctly answered the item by the total number of people who responded to the item. It is the percentage of individuals who correctly answered the item, and should be between 0.1 and 0.9 minimally. Usually, the best questions item difficulty is around 0.50. Discrimination is the degree to which a test item discriminates between persons who did well and those who did poorly. There are many ways to compute an index of discrimination. The simplest way is to divide the completed tests into a high-scoring group and a low-scoring group and then use the following formula. Index of discrimination is the number of persons score high minus the number of persons score low, divided by the total number of persons. For example, in a test for 10 students, 7 students score high, while 2 students score low, then item discrimination is 0.50. Generally, we should have item discrimination of 0.20 or higher for each item. There are 5 types of knowledge test items: completion, essay, match and G multiple choice, true-false. Multiple choice items are most reliable, but hardest to write. Today we discuss the concepts of validity and reliability of measurements and how they apply to research. However, measurement is often an overlooked area. Good research cannot be conducted without valid and reliable dependent measures. Please note that instrument validity and reliability and experiment validity are separate constructs. Instrument validity or reliability should be established before the study.